Hi, I'm Vinay Kumar Patel, and welcome to our guide on Process Safety Management, or PSM. Now you might be thinking, Process Safety Management. That sounds incredibly specific and maybe a little dry. And you're not wrong, but it's also the incredibly important, systematic approach that keeps industrial facilities from turning into front-page news for all the wrong reasons. Think of it as the detailed rulebook for preventing catastrophic chemical incidents. It's the difference between a controlled, productive chemical process and a very, very bad day involving explosions, fires, and toxic releases. So, while the name might not be flashy, its purpose is nothing short of heroic, protecting lives, communities, and the environment. This isn't just a good idea, it's the law. In the United States, the Occupational Safety and Health Administration, or OSHA, mandates PSM for facilities that handle highly hazardous chemicals above certain quantities. This regulation, formerly known as 29 CFR 1910.119, is built around 14 distinct, interconnected elements. Each element is a pillar supporting the entire structure of safety, from understanding the chemicals you're using to planning for the worst-case scenario. These aren't just boxes to be ticked. They are active, living components of a safety culture that requires constant attention and effort from everyone involved, from the CEO to the newest operator on the floor. Over the course of this video, we're going to embark on a grand tour of all 14 of these elements. We'll break down what each one means, why it's crucial, and how they all fit together to form a comprehensive safety net. We'll explore everything from hazard analysis and employee training to managing change and investigating incidents. By the end, you'll have a solid understanding of the PSM framework and appreciate why mastering it is absolutely essential for any organization working with hazardous materials. So, grab your safety glasses and let's get started. So, let's start at the beginning with the foundation of the entire system, Process Safety Information, or PSI. You can't manage the safety of a process if you don't fundamentally understand what the process is. It's like trying to cook a complex meal without a recipe, a list of ingredients, or any knowledge of whether you're using salt or sugar. PSI requires companies to compile and maintain a complete dossier of information before they even think about analyzing hazards. It's the essential library, the foundational text for everything that follows. Without accurate and accessible PSI, every other element of PSM is built on shaky ground, a house of cards waiting for a stiff breeze. This information is broken down into three critical categories. First, the chemicals. You need to know everything about the hazardous substances involved, their toxicity, permissible exposure limits, physical data like boiling points and flash points, reactivity data, what happens when it touches, say, water or air, and what happens if it's not stored or handled correctly. This is the know your enemy part of the plan. This data isn't just for chemists in a lab. It's vital for operators, maintenance crews, and emergency responders who need to understand the specific dangers they might face at any given moment. It's the chemical's resume, and you need to read it carefully. Next up is information about the technology of the process. This means you need a block flow diagram or a simplified process flow diagram. You need to document the process chemistry, establish the maximum intended inventory of hazardous chemicals, and define the safe upper and lower limits for things like temperature, pressure, flow, and composition. Essentially, you're drawing the safe operating envelope. This is the box you need to stay inside for everything to go smoothly. Straying outside these established limits is a formal invitation for trouble, and you need to know exactly where the edges of that box are. Finally, you need detailed information about the equipment in the process. This includes materials of construction, piping and instrumentation diagrams, PIDs, electrical classification, relief system design and its basis, ventilation system design, design codes and standards employed, and safety systems like interlocks and detection systems. It's the blueprint of your facility. Are the pipes made of a material that can withstand the corrosive chemical flowing through them? Is the relief valve sized correctly to prevent a vessel from overpressurizing? Having this information readily available is critical not just for safe operation, but for maintenance, troubleshooting, and any future modifications. All right, Once you've gathered all your process safety information, you have the tools to move on to the next crucial step, the Process Hazard Analysis, or PHA. This is where you and your team play the role of professional paranoids. The goal of a PHA is to systematically ask, what could possibly go wrong here? And then, how bad would it be? And finally, what can we do to prevent it or make it less bad? It's a proactive, methodical hunt for potential weaknesses in your process before they have a chance to become real-world incidents. It's about imagination, but a very structured and engineering-focused kind of imagination. OSHA requires that this analysis be performed using a systematic method, and there are several to choose from, like the what-if analysis, checklist, hazard and operability study, HAZOP, or failure mode and effects analysis, FMEA. The most common for complex chemical processes is the HAZOP. In a HAZOP, a multidisciplinary team, engineers, operators, maintenance staff, safety professionals, goes through the process section by section, using guide words like no, more, less, or reverse to brainstorm potential deviations from the intended design. For example, what happens if there is no flow in a cooling water line, or more pressure in a reactor? The PHA must address the hazards of the process, identify any previous incidents that had a potential for catastrophic consequences, and pinpoint the engineering and administrative controls in place to manage the identified hazards. It looks at the consequences of failure of those controls. What happens if our high-pressure alarm fails? What if the operator doesn't follow the procedure? This isn't just a paper exercise, it's a critical thinking session that results in a prioritized list of risks. It quantifies, or at least qualifies, the likelihood and severity of potential events, allowing the team to focus on the most significant dangers. The output of the PHA is a list of recommendations to reduce or eliminate the identified risks. This might be adding a new safety interlock, rewriting a confusing procedure, installing a better alarm, or changing a material of construction. The facility must then establish a system to promptly address these findings and recommendations, document what they did, and ensure the fixes are actually implemented. The PHA isn't a one-and-done event either. It has to be updated and revalidated at least every 5 years, or whenever a major change is made to the process, ensuring that the safety analysis remains current and relevant. So you've identified the hazards. Now what? You need to make sure everyone who runs the process knows how to do it safely and consistently. This brings us to our third element, operating procedures. These are not just helpful suggestions, they are the detailed, step-by-step written instructions for conducting every activity involved in the process. They are the script that every operator must follow to ensure the process stays within its safe operating limits. Think of them as the pilot's pre-flight checklist. It doesn't matter if you've flown the plane 1,000 times, you follow the checklist every single time because consistency is the bedrock of safety. These procedures must be clear, accurate, and readily accessible to employees. They can't be locked away in a manager's office. They need to cover every phase of operation, not just the normal day-to-day stuff. This includes initial startup, normal operations, temporary operations, and emergency shutdown, including the conditions under which an emergency shutdown is required, and the assignment of shutdown responsibilities to qualified operators. They also need to cover normal shutdown and what to do when starting up the process after a major shutdown or turnaround. Every conceivable state of the process must have a corresponding, well-documented procedure. A critical part of these procedures is defining the safe operating limits we talked about earlier. The procedures must explicitly state the consequences of deviating from these limits and the steps required to correct or avoid that deviation. For example, if the temperature in a reactor exceeds 200 degrees Celsius, the procedure should state what bad things will happen and exactly what the operator needs to do, like opening a cooling valve or initiating a shutdown. They also need to include information about the specific safety and health hazards of the chemicals and the measures necessary to protect employees, such as wearing personal protective equipment or using specific ventilation. Finally, like everything in PSM, these procedures must be living documents. They need to be reviewed as often as necessary to assure they reflect current operating practice, including any changes to chemicals, technology, or equipment. And crucially, the company must certify annually that these operating procedures are current and accurate. This ensures the documents on the shelf actually match the work being done on the plant floor, preventing a dangerous gap between theory and reality. It's about ensuring the map accurately reflects the territory. Having the world's best operating procedures is useless if no one is trained to follow them. This leads us directly to the fourth element: training. Every single employee, present and future, who operates a covered process needs to be thoroughly trained in the overview of the process and its specific operating procedures. This isn't just about reading a manual and signing a form. It's about ensuring deep comprehension and the ability to perform the job safely and correctly, especially when things aren't going according to plan. Effective training builds competence and confidence, turning procedures from mere words into ingrained actions. The training must emphasize the specific safety and health hazards of the process, the emergency shutdown procedures, and the safe work practices applicable to the employee's job tasks. An operator needs to know not just what button to push, but why they are pushing it, what hazards they are controlling, and what could happen if they do it wrong or at the wrong time. This initial training is required before an employee is ever allowed to work on the process independently. The employer has to certify in writing that the employee has the required knowledge, skills, and abilities to safely carry out their duties. But training isn't a one-time event. Memory fades, skills get rusty, and small unsafe habits can creep in over time. That's why PSM requires refresher training at least every 3 years, and even more frequently if necessary. The purpose of this refresher training is to ensure that employees understand and adhere to the current operating procedures. The employer also has a responsibility to consult with employees to determine the appropriate frequency for this training. It's a continuous loop of learning, practicing, and reinforcing the safe way of doing things, keeping everyone's skills sharp and their safety awareness high. And it's not just about the how-to, it's also about creating a record. The employer must keep a record of the training for each employee. This record should contain the identity of the employee, the date of the training, and the means used to verify that the employee understood the training. This documentation is crucial for accountability and for demonstrating compliance. It proves that the organization is not just hoping its employees are safe, but is actively and verifiably investing in their competence and well-being. So far, we've focused a lot on information, procedures, and people, but all of this relies on the physical equipment, the pipes, pumps, vessels, and valves, doing its job without failing. This is where our fifth element, mechanical integrity, comes in. The purpose of a mechanical integrity program is to ensure that equipment used to process, store, or handle highly hazardous chemicals is designed, installed, and maintained to minimize the risk of releases. It's the systematic care and feeding of your critical hardware to ensure it remains fit for service throughout its entire life cycle. It's about preventing catastrophic failures by catching problems when they are small. The mechanical integrity program applies to specific types of equipment, including pressure vessels and storage tanks, piping systems, relief and vent systems, emergency shutdown systems, controls like monitoring devices and sensors, and pumps. For each piece of covered equipment, the employer must establish and implement written procedures for maintenance. These aren't just generic fix-it-when-it-breaks instructions. They are detailed procedures to ensure that maintenance is performed consistently and safely, preserving the integrity of the equipment. This includes things like proper torque for bolts or specific welding procedures. A cornerstone of any good mechanical integrity program is inspection and testing. You can't just assume your equipment is okay, you have to go look. The program must include a schedule for periodic inspections and tests based on manufacturer recommendations, industry standards, and operating experience. For example, a pressure vessel might require ultrasonic thickness testing every few years to check for corrosion. A critical safety interlock might need to be functionally tested every year to ensure it works. The frequency is key. It has to be often enough to catch degradation before it leads to a failure. Of course, when inspections or tests find a deficiency, a thin pipe wall, a leaking valve, a malfunctioning sensor, it must be corrected. The Mechanical Integrity Program requires that these deficiencies are corrected in a safe and timely manner before they lead to a bigger problem. And all of this, the procedures, the inspections, the tests, the results, the corrections, must be documented. This creates a detailed service history for each piece of critical equipment, proving that it is being properly cared for and is safe to operate. It's the equipment's medical record, and it's just as vital. Some of the most devastating industrial accidents have been caused by a seemingly simple combination, a flammable chemical and an ignition source. Our sixth element, hot work permits, is designed to strictly control one of the most common and dangerous ignition sources, open flames or spark-producing activities. Hot work includes things like welding, brazing, cutting, and grinding. Performing these activities in an area where flammable gases or vapors could be present is like lighting a match in a room full of gasoline fumes. The hot work permit system is a formal, written procedure to ensure this is never done without extreme caution and multiple layers of protection. The employer must issue a hot work permit for any hot work operations conducted on or near a PSM-covered process. This isn't just a simple permission slip. It's a comprehensive safety checklist that serves as a contract between the person authorizing the work and the person performing it. The permit documents that all necessary fire prevention and protection measures have been implemented before the hot work is allowed to begin. It forces a pause, a moment of critical safety review, before a spark is ever generated. It's a formal documented timeout for safety. The permit itself must identify the object on which hot work is to be performed, the dates authorized for the work, and a checklist of safety requirements. This checklist is the heart of the permit. Has the atmosphere been tested for flammable vapors with a combustible gas meter? Are fire extinguishers and charged fire hoses in place and ready for immediate use? Have nearby drains, ducts, and flammable materials been covered or protected? Has a fire watch, a person whose only job is to watch for fires and be ready to sound an alarm, been assigned? The permit ensures all these questions are asked and answered before the work starts. The completed permit must be kept on file until the hot work operations are finished. This provides a clear record that safety protocols were followed. The hot work permit system is a classic example of an administrative control. It doesn't physically prevent a fire, but it creates a robust administrative barrier that makes a fire much less likely. It's a simple but incredibly effective tool for managing one of the most obvious and severe hazards in any industrial facility. It's about treating fire with the respect it deserves. Industrial processes are not static. They are constantly evolving. New technology becomes available, a different raw material is sourced, or maybe an operating procedure is updated. While change is often necessary for improvement, uncontrolled change is actually one of the most common root causes of major accidents. This is where our seventh element, management of change, or MOC, comes in. MOC is a formal process for reviewing and authorizing any proposed change to a PSM-covered process to make sure that the safety implications are fully understood and addressed before the change is implemented. It prevents a seemingly small, innocent change from having unforeseen and, honestly, catastrophic consequences. The MOC procedure applies to changes in process chemicals, technology, equipment, and procedures. It even covers changes to facilities that affect a covered process. The only exception is for replacement in kind, for example, replacing a broken valve with an identical new one. Anything else, from using a different supplier for a chemical to changing the alarm set point on a temperature controller, must go through the MOC process. It's designed to catch the ripple effect, those downstream impacts that might not be immediately obvious to the person proposing the change. The written MOC procedure has to address several key things. First, it must establish the technical basis for the proposed change. Why are we doing this? Second, and most importantly, it must analyze the impact of the change on safety and health. Will this new chemical react differently? Will this new piece of equipment have a different failure mode? The MOC process ensures these questions are formally asked and answered. It also requires considering any necessary modifications to operating procedures, updating safety information, and defining the required time period for the change. Before any change is introduced, all affected employees, including operators and maintenance personnel, must be informed of and trained on the change. You can't change the rules of the game and not tell the players. The process safety information and operating procedures must also be updated accordingly. The MOC process creates a formal paper trail for every modification, ensuring that changes are deliberate, well analyzed, and properly communicated, maintaining the integrity of the entire safety system. It's really the ultimate defense against the law of unintended consequences. You've designed a new process, or you've just completed a major modification to an existing one using your management of change procedure. Everyone is eager to get it up and running, but wait. Before you introduce hazardous chemicals into the system, there's one more critical checkpoint: the Pre-Startup Safety Review, or PSSR. This is the eighth element of PSM. The PSSR is a final verification to confirm that all the safety requirements have been met and that the facility is truly ready for a safe startup. It's the final all-clear signal, a systematic double-check to catch any last-minute issues that might have been overlooked during design and construction. A PSSR is required for any new facility and for any modified facility when the modification is significant enough to require a change in the process safety information. Think of it as the final exam before the process goes live. The purpose is to ensure that the as-built facility matches the as-designed safety specifications. Sometimes things look good on paper, on the P&IDs and in the procedures, but the reality on the ground is different. Maybe a valve was installed backward, or a crucial piece of instrumentation was never connected. The PSSR is the hands-on check to find those discrepancies. The review must confirm several key things. First, that construction and equipment are in accordance with the design specifications. This is often done through a physical walk-down of the system. Second, it confirms that all the necessary safety, operating, maintenance, and emergency procedures are in place and are adequate. You can't start up if you don't have the instruction manual ready. Third, for new facilities, a process hazard analysis must have been performed and all recommendations resolved or implemented before startup. You have to do your homework before the test. Finally and crucially, the PSSR verifies that training for each employee involved in operating the process has been completed. Introducing a new or modified process with untrained personnel is a recipe for disaster. The PSSR team, typically a multidisciplinary group of engineers, operators, and maintenance staff, formally documents that all these conditions have been met. Only after the PSSR is complete and all boxes are checked can the process be safely started. It's the final vital gatekeeper between a project and its operation. So you've implemented all these elements. Your procedures are written, your people are trained, and your equipment is maintained. But how do you know you're actually doing what you say you're doing? How do you ensure your safety systems are still effective and haven't degraded over time? The answer is our ninth element: compliance audits. A compliance audit is a systematic, objective evaluation to verify that the facility is in compliance with all 14 elements of the Process Safety Management Standard. It's kind of like having an external examiner come in to grade your safety program. OSHA requires that employers certify they have evaluated their compliance with PSM at least once every 3 years. This isn't just a quick look around, it's a deep dive into the records, procedures, and practices of the entire PSM system. The audit must be conducted by at least one person who is knowledgeable in the process. Often, companies use a team that includes a mix of internal experts from other sites and external, third-party auditors to ensure a fresh and unbiased perspective. The goal is to get an honest assessment of the health of the PSM program. The audit process involves reviewing documents, interviewing personnel at all levels, from managers to operators to maintenance technicians, and observing work practices in the field. Are the operating procedures really being used? Are MOCs being completed correctly? Is the mechanical integrity documentation up to date? The auditors are looking for evidence of both compliance and non-compliance. They are hunting for gaps between what the PSM standard requires, what the company's own procedures say, and what is actually happening in practice. The result of the audit is a formal report of the findings. This report identifies any deficiencies or areas for improvement in the PSM program. The facility must then promptly determine and document an appropriate response to each of these findings and certify that the deficiencies have been corrected. The two most recent compliance audit reports must be kept on file. This creates a cycle of continuous improvement. Audit, find gaps, fix gaps, and then audit again in 3 years to ensure the fixes have held and to find new areas to improve. It's the mechanism that keeps the entire PSM system honest and effective over the long term. Despite the best prevention efforts, sometimes things still go wrong. An alarm is missed, a pipe leaks, a safety system fails to activate. These events, from minor near misses to major incidents, are valuable, if tragic, learning opportunities. This brings us to our 10th element, incident investigation. The PSM standard requires that every incident which resulted in or could reasonably have resulted in a catastrophic release of a highly hazardous chemical must be investigated. The key phrase here is could reasonably have resulted in. This means you must investigate near misses with the same rigor as actual accidents, because honestly, a near miss is just an accident that hasn't happened yet. The investigation must be initiated as promptly as possible, but no later than 48 hours after the incident occurs. Time is of the essence. Memories fade, evidence can be disturbed, and the conditions that led to the event can change. The investigation must be conducted by a team that consists of at least one person knowledgeable in the process involved, and should also include a contract employee if the incident involved the work of a contractor. Including operators and maintenance personnel who are familiar with the process is also critical to getting a complete picture of what happened. The goal of the investigation is not to assign blame. The goal is to find the facts and identify the underlying root causes of the incident. It's easy to stop at operator error, but a good investigation asks why the operator made the error. Was the procedure confusing? Was the training inadequate? Was the alarm not noticeable? The investigation team must dig deep to uncover the systemic failures in the management system, the failures in the other PSM elements that allowed the incident to occur. This focus on root causes is essential for preventing recurrence. The investigation culminates in a formal report. This report must include the date of the incident, the date the investigation began, a description of the incident, the factors that contributed to it, and, most importantly, a set of recommendations to prevent it from happening again. The company must then establish a system to promptly address and resolve these report findings and recommendations. The lessons learned are then shared with all affected personnel, including employees and contractors, to ensure that the entire organization learns from the mistake. It's about turning failure into future safety. No matter how robust your prevention systems are, you must always be prepared for the possibility that they could fail. What do you do when a hazardous chemical is actually released? This is the focus of our 11th element, emergency planning and response. Every facility covered by PSM must establish and implement an emergency action plan for the entire plant. This plan is the playbook for what to do in a crisis. It ensures that in the chaos and confusion of an emergency, there is a clear, predetermined, and well-rehearsed set of actions to protect workers, the public, and the environment. The plan must include procedures for handling small releases, but it must also address the worst-case scenarios. It needs to define the procedures for emergency escape and how to alert employees that an emergency is happening. Think alarms, horns, and public address systems. It must specify the preferred means of reporting fires and other emergencies. Crucially, it must include procedures for employees who remain behind to perform critical plant operations before they evacuate. Someone has to shut things down safely, and they need to know exactly how to do it and when it's time to leave. The plan must also include procedures for rescue and medical duties for those employees assigned to perform them. And it must designate an emergency response coordinator and outline the lines of authority and communication. In an emergency, you need a clear chain of command. The plan should also detail how to coordinate with outside emergency responders like the local fire department. These external agencies need to be aware of the specific hazards at your facility so they can respond safely and effectively. This often involves joint training exercises and sharing of critical process safety information. Of course, a plan sitting on a shelf is useless. The plan must be trained on. Drills must be conducted. Alarms must be tested. Employees must know the evacuation routes and where the designated assembly points are. They need to be able to react instinctively and correctly when an alarm sounds. This plan is a living document, reviewed and updated periodically to reflect changes in the plant or in emergency response capabilities. It's the ultimate insurance policy, the one you hope you never have to use, but the one you absolutely must have. Throughout this discussion, we've talked about what the employer must do, but a successful PSM program cannot be a top-down mandate. The people who work with the hazardous processes every single day, the operators, mechanics, and technicians, have a unique and invaluable understanding of the risks. Our 12th element, employee participation, recognizes this and requires employers to create a formal plan to involve employees in the development and implementation of the entire PSM program. It's about building a culture of safety ownership, not just compliance. The employer must consult with employees and their representatives on the conduct and development of the process hazard analyses. Who better to ask what could go wrong than the person who has to deal with the process's quirks on a daily basis? Their practical experience can identify hazards that engineers might miss on a drawing. This collaboration makes the PHA process far more robust and realistic. Employee involvement is not just a suggestion, it is a required part of the process. This participation extends to all other elements of PSM as well. The standard requires employers to provide employees and their representatives with access to all the information covered by the standard, including PHAs and all other documents required to be developed. This transparency is key. It empowers employees to be active participants in their own safety. If an operator sees something that doesn't match the operating procedure or a P&ID, they need to feel empowered and have access to the information to raise that concern effectively. The written plan of action for employee participation ensures this isn't just a vague promise. It has to be a concrete plan. How will employees be consulted? How will they access information? How will their input on procedures, training, and investigations be incorporated? By formally integrating employees into the fabric of PSM, companies create a powerful continuous feedback loop. It turns the entire workforce into a team of safety watchdogs, fostering a proactive culture where everyone feels responsible for preventing incidents. Safety becomes everyone's job, not just the job of the safety department. Modern industrial facilities rarely operate in isolation. They rely on a host of outside contractors for everything from specialized maintenance and construction to janitorial services. These contractors and their employees work alongside company employees, often on or near the most hazardous processes. Our 13th element, contractors, is about ensuring that these contract workers are integrated into the facility's safety program and do not introduce new hazards. It holds the host employer responsible for the safety performance of the contractors they bring onto their site. The responsibilities are twofold, applying to both the host employer and the contractor. First, the host employer has a duty to evaluate the safety performance and programs of any potential contractor before hiring them. You wouldn't hire an accountant without checking their qualifications. You shouldn't hire a contractor without checking their safety record. The employer must obtain and evaluate information regarding the contractor's safety performance and programs to ensure they are equipped to work safely in a high-hazard environment. Once a contractor is selected, the host employer must inform them of the known potential fire, explosion, or toxic release hazards related to their work. They must explain the applicable provisions of the site's emergency action plan. The host employer is also responsible for maintaining a contract employee injury and illness log related to the contractor's work in process areas. This ensures accountability and tracks the safety performance of contractors while they are on site. It's about making sure everyone is playing by the same safety rules. The contractor in turn has responsibilities. They must ensure that their own employees are trained in the specific hazards and work practices necessary for their job. They must advise the host employer of any unique hazards presented by their own work. And crucially, they must ensure that each of their employees follows all the safety rules of the facility, including practices like hot work permits and safe work procedures. This element creates a seamless safety umbrella that covers everyone on site, regardless of whose name is on their paycheck. We've spent this entire time talking about the importance of compiling and sharing information, process safety information, operating procedures, incident investigations. But what happens when some of that information is a company's proprietary secret source? A unique chemical formula or a novel process technology that gives them a competitive advantage? This is where our 14th and final element, trade secrets, comes into play. This element provides a way to balance the legitimate need for companies to protect their intellectual property with the absolute, non-negotiable need for employees to have all the information necessary to work safely. The basic principle is simple. Safety trumps secrecy. The employer must make all information necessary to comply with the PSM standard available to those persons responsible for compiling the PSI, developing PHAs, writing operating procedures, and conducting investigations, regardless of whether it's a trade secret. You cannot withhold critical safety information from the people who need it to prevent a catastrophe by claiming it's a secret. The right to a safe workplace is paramount. This means that employees and their designated representatives must have access to any trade secret information contained within process hazard analysis reports, incident investigation reports, or any other document required by the PSM standard. If an operator needs to know the specific reactivity of a chemical to do their job safely, the company has to tell them, even if the exact formulation of that chemical is a trade secret. The information required for safety must be shared. However, the standard does allow employers to require the people receiving this information to sign confidentiality agreements. This is the compromise. The information is shared, but the recipients are legally bound not to disclose it outside of their necessary job functions. This prevents the information from being used for commercial purposes or being leaked to competitors, while still ensuring it gets to the operators, engineers, and safety professionals who need it to keep the facility and everyone in it safe. It's a pragmatic solution that ensures the free flow of safety information, which is the lifeblood of the entire PSM system. And there you have it, a whirlwind tour through the 14 elements of process safety management. From the foundational knowledge of process safety information to the critical feedback loops of audits and incident investigations, each element is a vital thread in a complex safety net. When woven together and implemented with diligence and commitment, these elements do more than just satisfy a regulatory requirement. They create a robust, resilient system designed to prevent catastrophic accidents. The ultimate goal, as we've seen, is to protect what matters most: the lives of employees, the well-being of the surrounding community, the company's physical assets, and the environment we all share. But remember, PSM is not a destination. It's a continuous journey. It's not a certificate you hang on the wall and forget about. It is a living, breathing culture of vigilance that requires constant effort, resources, and commitment from every single person in an organization. Complacency is the enemy. The work of safety is never truly done. The systems must be maintained, the procedures updated, the training refreshed, and the commitment renewed day after day. It's a never-ending story, and the protagonist is a culture of proactive safety. So I encourage you to take this knowledge and dig deeper. Whether you're a manager, an engineer, an operator, or just someone interested in how our industrial world works safely, there is always more to learn. Ask questions within your own organization. Champion the principles of PSM. Prioritize safety not just as a program, but as a core value. Because by mastering these principles, we can ensure that the facilities that power our world do so safely and responsibly for everyone. Thanks for watching.